if you're looking at number 1, I want you to read it right now. It says sodium metal and water, they react to form sodium hydroxide and hydrogen gas. What mass of Na will react with the excess water to produce 15 grams of NaOH? So what mass of Na, right? So when they want mass of Na, they want grams of Na. So mass is grams. And they said it's going to make 15 grams of NaOH. So these problems are kind of like you're doing the same thing over and over and over again, but you just have to be really precise, and you have to make sure the steps, right? So the first thing you need to do is change grams to mole. And then what you need to eventually do is use the mole ratio train to get moles here. And then you go back to grams. Okay, that's what you're doing most of the time over and over again. So the first thing you have to do is grams to moles. And to go from grams to moles, the step is you have to divide by the molar mass. So find the molar mass of NaOH. Na is 23, plus oxygen is 16, plus hydrogen is like 1. This adds up to about 40. So you got to divide by 40. It's grams divided by molar mass to get moles. So 15 divided by 40. And I get 0.375 moles. Now you might be used to doing like mole ratio train from left to right, but you can ride the mole ratio train from the right to left. It doesn't matter. You can go anywhere that you need to go to using mole ratio train. Even if you start at the end, like right now we're starting at the end, we can go toward the front. So this thing, in order to go to the front, it's going to be, what's the mole ratio? It's going to be 2. Like you came from a 2. That 2 is from there. I mean, you're going to a 2. And you also came from a 2. So that's where these 2's come into play, okay? It's a 2 there and a 2 there. So I'm going backwards to the front. So it's 2 over 2. So when you multiply something by 2 over 2, it's going to be the same. The number doesn't change. So you're going to end up with 0.375 moles here. And then you have to change it to grams. To go from moles back to grams, what do you need to do? Yes, Ronson? Yeah, very nice. You have the times by the molar mass. And this time it's the molar mass of Na. Okay, so multiply this by 23. So multiply by molar mass, which is 23. And my final answer I got is around 8.625 grams, around there. And so my final answer is C, 8.6 grams. So what did I do here? I changed the grams that they gave me to moles. And then I rode the mole ratio train to find moles of this. The train was a 2 to 2 train. Because I'm going to a 2 and I came from a 2. So the number didn't change at all, but now it's moles of Na. And so you have to take one final step by multiplying by the molar mass of Na to get grams. And the molar mass was 23 for Na. okay? 15 grams, changed it to moles, and then you rode a 2x2 train to get moles of this, and then you went back to grams. That's essentially the move, okay? All right. Let's move on to, let's say, number 2. So number 2, they give you this reaction, right? Number 2, they give you this reaction, and they say if the reaction below, if 12 moles of aluminum hydroxide, so if 12 moles is consumed, how many moles of oxygen gas is produced? They want to know moles of oxygen gas. So, because you're already in moles, you can ride the mole ratio train right away. You don't have to change to moles because you already have moles, okay? And the train you have to ride is what you have to figure out. It's a 3 train. You're going to a 3, and you came from a 2. So it's a 3 to 2 train. That's where you get the 3, okay? You get the 3 from right here. You get the 2 from right here. Where you're going, where you are going, right? Where you came from. That's how you ride the train. Where you came from. I came from a 2, I'm going to a 3. So it's 12 times 3 divided by 2. 18 moles of O2, and your answer is E for 18. Okay. All right. Let's check out number 3 really quick. A lot of it's kind of like the same stuff, but they tweak, they do little tricks and they tweak little things here and there per problem. So it says what mass of CO2 is produced. So I think they want this in grams. And they say I have 2.94 grams of this. And they say that this is excess. Later on, you're going to see there's sometimes you have to do limiting reactant, but so far you don't have to worry about limiting because they tell you that if this is excess, then you know that this is limiting. So again, all you have to do is change grams to moles, then ride the mole ratio train right here to get to moles, and then go back to grams. That's what you're doing. That's pretty much what you're doing over and over again, okay? You just gotta do it carefully and make sure you're calculating it right. So, to go from grams to moles, you have to divide by the molar mass. The molar mass of this, right? Na2CO3. So, on the side here, if you want, you can add up Na2CO3, 23 times 2 plus 12 carbon plus 16 times 3 for oxygens, the 3 oxygens. You add that up real quick. And I got around a 106. This is the molar mass. So it's 2.94 divided by 106, and I got 0.02774 moles. Looking at this, I realized something, and this is very tricky. I don't see any coefficients. Right? I don't see any large numbers here. And so you you might have thought, oh, it's all 1, 1, 1, 1, 1. But when you don't see any numbers, any coefficients, it might not be balanced. It might not be balanced for you. So let's try to balance it and make sure we're good. There needs to be a 2 here because there's 2 NAs. But that makes 2 chlorines, so I'm going to put a 2 here. And then now it's balanced. Luckily for a problem like this though, it wouldn't really matter because you're going to CO2 and you came from here. So the mole ratio is just 1 to 1. So I was very lucky. If you didn't even balance it, you still got the answer correctly because it ended up being 1 to 1 ratio. So if it's 1 to 1, you know, this number doesn't change, right? So you end up with 0.02774. And then you got to go to grams. So this number you have to multiply by the molar mass of CO2. So carbon is 12. Oxygen is 16 times 2. Is that 44? So multiply this by 44 to get grams. And I get A 1.22 grams. So 2.94 grams. So starting all the way from the beginning. You started off with 2.94 grams, divided by the molar mass to get moles. Make sure the reaction is balanced. It's balanced like that with 1, 2, 2, 1, 1. But I'm going to CO2. So I'm going to a 1, so I'm going to put 1. I came from a 1, so that's going to go on the bottom. That means the moles don't change when I get to moles of CO2, and then change it to grams of CO2 by multiplying by CO2's molar mass. Yeah? Okay, number 4. I don't think I need to do this, so I'm not going to do it. They gave you moles, and they just want you to change to grams. Remember, moles, if you're trying to go from moles to grams, you have to multiply by the molar mass. And so you're just going to multiply by NaCl's molar mass, okay? You can do that one on your own, just so you're sure of it. Let's look at number 5. Angel, can you stop talking back there? Thanks. How many grams of H2O will be produced if, yes?
Unbalanced.
Oh, unbalanced. Very nice. So, you see, you should always check, you know? And especially when there's no numbers. You know how there's like no coefficients? There's like no numbers. There's no 2s. There's like the big numbers in front. There's no numbers. So you got to balance it, yeah? So maybe a 3 here. Because a 3 here because there's a 3. This is an arrow, right? And since there's 4 oxygens here, I'm going to put a 4 here. But that made it 8 hydrogens. So maybe a 4 here as well. So if it's a little too, 4H2, 3Fe. They even told you it was unbalanced right here, right? Plus 4H2O. And then like double check, double check that everything's good. You have three FEs, 4 O's. This makes it 4 O's. And then 8 hydrogens and 8 hydrogens. So balanced. Okay, and they want grams of H2O. That's going to be your final answer. And they started you off with, if they said 750 grams of Fe produced. Okay, 1 second. Okay, so it says, okay, how many grams of H2O will be produced if 750 grams of Fe is produced? So you got to change, it's the same thing. You got to change this to moles. Then write the mole ratio train to go to moles here, and then back to grams. So 750 divided by Fe, right? The molar mass of Fe. So you just go over here. 750 divided by 55.845. And I got 13.43 moles. Now the question is, what's the mole ratio? The mole ratio train. I'm going to a 4. I have to go to the question mark. They want to know about H2O. I'm going to a 4 and I came from a 3. Right? So it's this times 4 divided by 3. And that gets me this answer. 17.91, something like that, moles. And then you have to change that to grams. So multiply that by the molar mass of water. Molar mass of water is like around 18.02. And final answer, I get 322 grams. Around 322 grams. Okay, 750 grams. Change it to moles by dividing by the molar mass. Right? This is the divide by the molar mass of Fe. Then you get this, right? And then you have to multiply by 4 divided by 3 because you're going to a 4. You came from a 3. Multiply by 4, divide by 3 because I'm going here and I came from here. And then you get this. And then from there, you got to just change to grams. Multiply by H2O, molar mass. 322. All right? Okay, Cu. I mean, this one, copper, number 6. I see numbers here. I see a 2 here and a 2 here, so I'm assuming it's balanced. It doesn't say it's unbalanced, so I'm going to assume it's balanced. They say I have 5.8 moles of AgNO3. This time they gave you moles, right? They already gave you moles. So now you can just ride the mole ratio train right away. You don't have to go grams to moles anymore because they gave you moles. And they want to know moles of Cu. So, to go to the front, you have to write the mole ratio train, but you can multiply backwards, okay? Mole ratio train. You're writing to a 1 and you came from a 2. So it's 5.8 times 1 divided by 2. So you just cut it in half, right? 2.9 moles. And that's your answer. A for 2.9 moles. They gave you 5.8, right? 5.8 moles of AgNO3, and they want to know how many moles of Cu is needed. Well, if you have 5.8 moles of AgNO3, you need half of that. Do you see how it's like this is a 1 to 2 ratio? So if you had like 1 million of these, you're going to need 2 million of these. If you have 5.8 of these, you're going to need 2.9 of these. Half of that. Because it's 1 to 2. 1 to 2. Okay. Number 7, you can solve that on your own, right? It's just moles to grams. The hard part was, would you know how to write the formula for sodium chloride? Yeah, NaCl, very simple formula. Remember, you have to look at their charges though, and NaCl happens to be +1 and -1, so it is just 1 to 1. What if instead of sodium it said magnesium? What would be the formula? I'm gonna try to stay away from this part because this part would be like first semester. When you had to when I gave you name and you had to find the formula, and I give you the formula, you had to find the name. But what would be the formula for magnesium? Magnesium's charge, does anyone know? It's in the second column of the periodic table. +2. Chlorine's charge is -1. And remember how you have to kind of crisscross their charges or whatnot? This would be it's MgCl2. Okay? That's how you would do it. You would look at the charges and crisscross. That would be magnesium chloride. But in our problem, it's sodium chloride, so that's great. It's much easier. It's just NaCl. Even if you didn't look at the charges, you would end up with NaCl. So okay. Number 8, you can do on your own. It just says, what is the molar mass? So you have to add up the molar mass carefully. Do you know what to do with this 2 outside the parentheses? I would add up NH4. I would add up whatever's in the parentheses and then multiply it by 2. So nitrogen is 14, hydrogen is 1, but there's 4 of them. So this is what? 18, right? This is what's in the parentheses, 18. But there's a 2 outside. So I'm going to multiply it by 2. So that's 36. Plus, I have a carbon and 3 oxygen. Carbon is 12, plus oxygen is 16 times 3. 36 plus all that. So you just kind of add everything step by step, right? So 36 plus 12 plus 16 times 3, 96. I keep saying I'm not going to do it and that you should just do it, but I end up doing it, right? 96 grams per mole. You're just adding them all up carefully. NH4, add that up. There's 2 of them. Multiply by 2. Then add a carbon, and then add 3 oxygens. You have to add up the total, okay? Okay, I want you to try number 9 solely on your own. I'm going to jump to one that, and number 10 too. Again, all you're doing is, if they give you grams, look, I'm doing it again. But if they give you grams, right? All you have to do is figure out what they gave you. They gave us NO2. And then it says how many grams of oxygen produced. So the question is this. Change it to moles. and then ride the mole ratio train to get moles over here, and then go back to grams. What is the train though? The train here is 1 to 4. To ride over, it's 1 to 4. Okay? You try doing that. Let's look at number 10. 10 you can do also. This time, it's even easier because they gave me moles already. They tell me I have 10 moles of H2O. And they want to know this. So, since they gave me moles already, I can ride the mole ratio train right away. It's 4 over 6. So that's 40 divided by 6. 6.67 or 6.6 forever. This is fine. And then you have to change it to grams, okay? You have to multiply by H3PO4. All right, number 11, another like freebie. Like I gave you such easy questions randomly just so you get some points. They just want to know which element has this molar mass. So you just look up the red numbers on the periodic table here. Find 30.974 and that looks like it's phosphorus. Okay. All right. Now, here we go. Number 12. This is one of those things where it's a limiting reactant problem. They're going to give you grams of two things. What do you have to do? So read the problem carefully. They said you have 138 grams of this. And you have 54 grams of this. And they want this. How do you go about doing this problem? Anyone know how to do this one? Bronson? Try them both. You guys, do this one to moles, then do this to moles, and then go back to grams. Do the same thing with this. Go to moles, and then go to moles, and then change it back to grams. Whichever one yields less grams, that's going to be how much grams you can actually make. Whichever one's less is the answer. So this is a really good question. I'm actually going to pause this for a second. Okay. So at least you should have got 3 moles and 3 moles. They both ended up being 3 moles. But here's the key now. The mole ratio trains. This one, the mole ratio train is 1 to a 3. So it's going to be 1 to a 3. So 3 times 1 divided by 3, and you end up with 1 mole. The other one, though, is a 1 to a 1. There's a 1 here. So it's 1 to a 1. You end up with 3 moles. Which one do you think is going to be less? 1 mole or 3 moles? This 1 mole is going to give you less, okay? You can change them both if you want. Change them both to grams. Whichever one is less is the answer. But since this is 1 and this is 3, I know it's going to be the 1. So 1 mole times NO molar mass times NO molar mass, which is 14 for nitrogen, 16 for oxygen, that's 30. Oops, I'm going to the wrong spot, right? So I did this completely wrong. Did none of you catch that mistake?
I think what's this, how many grams of nitric acid?
Yeah. So, this happens a lot, and I see students doing the same thing. They go to the wrong spot sometimes. And I just did that. I almost never do that, and I just realized that even I can definitely make such an easy mistake, but then I realized none of my answers were there. So, I'm trying to go here. So it's 2/3. And this one, the mole ratio should have been 2/1. Right? So this is 6 moles. That's going to make 6 moles here. And this bottom one is going to make 6/3, which is 2 moles. So 2 is going to be the answer. 2 moles times, to get to the grams, you have to multiply HNO3 molar mass. H is 1, plus nitrogen is 14, plus oxygen is 16 times 3. And I got 126. So C as your answer. Okay? All right. Number 13. You can try. 14 is just like the one we just did. Okay, number 15. So let's try this one. I want you to realize what they're saying here, okay? Lead nitrate, which is this, can be decomposed by heating. What is the percent yield of the decomposition reaction? This is a percent yield problem, everyone. Okay, what is the percent yield if 9.9 grams are heated to give 5.5 grams of this? They're not saying that this is, something that you need. That part, the 5.5 right here, do you know what this is? Yeah, that's the actual. Very good. Percent yield is actual divided by theoretical times 100. And what you needed to realize is this 5.5 that they're giving you, that's the actual. The 5.5 grams is the actual. So you need to calculate the theoretical and then calculate the percent yield. So using 9.9 grams, I want you to change it to moles. And they're talking about this, right? So use that to go mole ratio train, and go back to grams. And then whatever you get here, that's the theoretical. Okay? What you get here is the theoretical. This one was a little tricky because this molar mass is a little intense. PbNO3 with the 2 outside. Anyone know what Pb is, molar mass? 207.2? 207.2 plus 2 nitrogens plus 6 oxygens. So 9.9 divided by 331.2. I got like 0.02989. The mole ratio is 2 to 2. So the moles are not going to change. And then you got to change it to grams. Multiply it by PB and O. PB and O. And so I got 6.67 grams. That, everyone, is the theoretical. So it's 5.5 divided by 6.67 times 100. And I got around 82%. %. Okay. Oh, that was it? Your test only had 15 questions. Okay, there are a few that I did skip over. I would really highly recommend you try them out, like number 14, 13, just to make sure you know how to do it. I'll pause. I'll stop the recording there.